The back page of this, if you got the revised version, the numbers might not match up, but same questions. So we cross off that one if it's on yours. And then this one here, Kendra graphed this function, f of x equals negative 13 to the x power. Write a function that is a reflection of the function about the horizontal line y equals 0. Y equals 0 means that it's cutting through the y-axis. So here's my y-axis. And it's cutting through it at 0. So like here's when y is 0. And that would be this horizontal line. That horizontal line is the same line as the x-axis. So really when we're reflecting over this horizontal line, it's a reflection over the x-axis. And if you reflect over the x-axis, all you do is you put a negative in front of it. And because the negative's already there, we have a negative times a negative, which would turn into a positive. And so we'll just call this, instead of f of x, we'll call it g of x. So our g of x would just turn into positive 13 to the x. So positive 13 to the x goes like this, and negative 13 to the x goes like that. So it's just a reflection over that x-axis. So that's all number 12 is. And then number 13 right below it here, write the equation of each function after the translation described. So this was a lot of the stuff that you did in Mathia. If we're going 3 units down, 3 units down means you just subtract 3 in the back. So you have to be real careful that you are writing this in the back of the function. So we start with 7 to the x power. Make sure it looks like the x is in the exponent. It's an exponential function. And then down 3 means we just put minus 3, and that should not be in the exponent. And I just used h of x. You could use any letter here you wanted. So let's just use h of x here also. So we're starting with this one, and we're translating it 2 units to the left. So if it's 2 units to the left, that means that we're going x plus 2 in the parenthesis, or like in the exponent. So we start with what we have here, the 5/6 to the negative x. And what's up here, that is our x plus 2. That would shift it to the left too, because the parentheses is really like your exponent here. Okay, and then number 14, translate the graph of the function f of x 5 units to the left. So let's start with that. We pick a few of the points here. So this one is at 0, 1, and if we shift it 5 left, it's going to be here. And then if we pick another point here, let's say this one hits right there at 4, and we go 5 units to the left, it'd be here at -1. So I'm going to put that dot here. And it's still going to approach the same horizontal asymptote. When you shift left or right, the horizontal asymptote doesn't change. So it'll grow similar to what you see there. So something like this. And then it'll approach that x-axis here still. And it says graph the new function g of x. So this is my g of x function that I just graphed. So you should just show a couple of these points plotted there. Okay, and then down towards the bottom, we're just trying to describe what each of these pieces does to the graph. So again, this was in your Mathia a lot. So this negative out front reflects it over the x-axis. So that's the first thing that's happening. And then we've got this -1, and think of that as being like in the parenthesis. So if it's -1 in the parenthesis, it actually goes to the right one. And then we've also got this +9 in the back, and a plus or minus in the back moves it up or down. So this is going to move it up 9. So those are the 3 things that's happening to that function there.